Hi, welcome to my video introduction about my project on how to automate malaria diagnosis. So my project's about accurately diagnosing malaria. There's 200 million cases of malaria every year with about 400,000 deaths. Manual counting is kind of the standard way it's done, but this isn't standardized throughout the world and accuracy can vary. So automatic counting could be more fast, more standardizable, and possibly much more accurate. So my data center process, I used a Kaggle data set of about 28,000 images of cells. There was no class imbalance as both classes were equally represented. We compared both classes and looked to determine patterns to improve classification. So we created a simple convolutional neural net, complex convolutional neural net, as well as convolutional neural net using transfer learning. And you can see here on the test sets, the accuracy score was highest on the complex convolutional neural net, so we selected that as our final model. And you can actually see here over the epochs, the model's training. And you can see both on the train and validation sets, they're pretty even, so we're not worried about overfitting, so that was encouraging. Here's the confusion matrix. You can see here on the left diagonal, the correct classifications, and here on the right diagonal, the incorrect. So this is basically the false negatives and the false positives. You can see though these are relatively small numbers, so that was very encouraging. In terms of the false negatives, false positives, so for false negatives, if you look here, you can see that there are these like very subtle bumps in the middle. But because they're very subtle, we think the model didn't think they were in fact parasites, so that's why I predicted uninfected when the patient was infected. In terms of false positives, the model predicting infected when the patient's uninfected, you can see here there's these two red bumps that are very apparent. So clearly the model thought those were parasites. So that's why there was an incorrect misclassification. So to conclude, we found that non-parasite impurities were often misrecognized as parasites, which caused misclassification. So we recommend screening through the data as much as possible and try to use the highest image quality possible to minimize ambiguity of cells. Also, in terms of hyperparameters, we found that complexity of the model and order of convolutional layers had the most effect in boosting performance. Also, we'd recommend beginning with a simple convolutional neural net and then building its complexity iteratively, and try different orders for the convolutional layers to find what best works. And in the future, we want to try to build a model with multiple cells, because in data collection, this would be quicker, and it would provide the model more information. So this could possibly allow the model to find more patterns, which could boost performance even further. Thanks for your time. I hope you enjoyed.